This is problem number 8 from section 2.1. In this problem they say, the table to the right lists the annual hours worked by the average worker in a country for selected years. Now if you look at the right here, they start in 1970, 2020 hours is the average number of hours worked by a worker in this specific country. And then in 2010, it's now 1,570. So there's been quite a significant drop. But keep in mind they said average. So it says let x represent the number of years after 1970. So that means our x values, although they say 1970, 1980, 1990, this is really 0 because it's years after 1970. This is 10 because it's 10 years after 1970. This is 20, this is 30, this is 40 because those are the number of years after 1970. Find a formula in slope-intercept form for a linear function f that models the data. Now because they use the word average, and because as you go through this data and you try to find the slope between these individual points, you'll notice the slopes are going to be slightly different. So because they say average in here, I'm assuming we want to start with the first coordinate and the last coordinate and just find the average slope. What's the average change year to year? So first of all, the coordinate of for 1970 and 2020 hours, because the x part is the years after 1970, this is really the coordinate 0, 2020. And because this is 40 years after 1970, we're going to say that this is 40, 1570. That's the first thing we should do to start this problem. Now we want to write this, and they say slope-intercept form. So let's go ahead and use point-slope form to like start this, and then we can put it in slope-intercept form. So we need to find the slope first. We're going to call this x1, and this is y1. This is x2, and this is y2. We're going to find the slope by doing 1570 minus 2020 over 40 minus 0. Now if I do 1570 minus 2020 in the calculator, it gives me negative 450 over 40. So then when I go ahead and divide those, I get negative 11.25. So my slope here is negative 11.25, meaning every year the average worker basically works 11.25 hours less. So I can go ahead and start writing this equation for part A. I'll write that here, part A. And I can say that in slope-intercept form, which is here. So remember I said I might use point-slope form here. Well, actually I don't have to, because if you look at this coordinate, that's the y-intercept. This is the slope, and I should have put m here. So I can go ahead and say y equals negative 11.25 x, and then I have my original amount of hours essentially, which was starting at time 0, which this is number of years after 1970. So this is my starting hours. So I can say that that's my y-intercept, which is plus 2020. So this is the answer to part A. Now part B, it says interpret the slope of the graph of y equals f of x. So what's the slope mean? Well, we just interpreted it a second ago. So negative 11.25 means the average worker works 11.25 hours less each year. Now remember that's an average there. So it's not every single year they work 11.25 hours less, but that's the average over time. And then part C, estimate the annual hours worked in 2014. So again, 2014 is outside of our data set, so they're asking us to do a prediction, right? So we take our, this is extrapolation essentially. We're going to take our 2014 and find the number of years afterwards. So years after, we're going to do years after. That's 2014 minus 1970, 44. So we're going to use 44 for our x value, plug it into this equation. So we're going to say y equals negative 11.25 times 44 plus 2020. Use our calculator. So negative 11.25 times 44 plus 2020. That means they're going to be working 1,525 hours. So that's the estimated number of annual hours worked by a worker in 2014. 1,525 hours.